Hello, today we are going to teach you the concept of second derivative. So why we need to discuss the second derivative? So we know the first derivative we done the last term. So before that, so when we're dealing with second derivative, so for example, we're talking about velocity and acceleration. So we all know velocity is derivative of displacement with respect to time. So that's also, we can use x dash. So acceleration, we can say it's a derivative of velocity with respect to time. So if I'm going to replace the velocity, so velocity is a dx divided by dt. So this is notation has become, what we do is what we call the second derivative, so which is differentiate twice of the displacement, which will be acceleration. So in the general term, if I have a y equal to fx, so first we will say that first derivative is dy with respect to x. Then if I'm going to do derivative again, so we say d differentiate this derivative with respect to x again. So this is the notation. So which this also we can written as d square y and divided by dx squared. So this is the notation for the second derivative. Or we can say is y double dash. So derivative twice. Or we can say is f double dash. So this is all the notation for second derivative. So let's have a look at some examples. So we have a look at example number 1. Okay, so take the first example. So we want to differentiate twice. If I say given, so y equal to, so the function is x to the power 4 plus 2x cubed minus 4x squared plus 5. So can we find out what is double derivative of y? So let's solve that. So first we need to do first derivative, so which is 1 dash. So we know it's 4 to the front, so it'll be 3 plus 6x to the power of 2 minus 8 x to the power of 1 and plus 0. So that's a first derivative. Then we will be differentiate the first derivative. So be 12x squared plus 12x minus 8. So that's my second derivative. So you can see the original equation was x to the power 4, which is a quadratic function, and one derivative, first derivative will be cubic function, and second derivative become quadratic function. So this is example 1. So let's have a look at another example. Example 2. So I'll give you why this time is a little more complicated. So example 2 is y equal to, we have 4 square root x to the power of 5 divided by 3x squared. So we need to find a double derivative. Okay, let's do the first. I would like to simplify this function because you got x to the power 5 and then you have x to the power 2 underneath. So what I'll do is I'm going to change the top is x to the power of 5 over 2 and the bottom is x to the power of 2. So now becomes, so we put a 2x term 2 into the 1 term, so which is 5 over 2 minus 2. So the answer will be 4 over 3 x to the power of, so 1 and on 2. So this is a lot of simpler case, isn't it? So, okay, let's do the differentiation. So first derivative, do one step at a time. So differentiate x to the power half will be 4 times 4, 3 times by half times by x to the power of half minus 1. So the answer 4 cancel with that. So it'll be 2 over 3 x to the power of negative half. So then we put it back to 3. All right, put it to bottom, so it become positive. Okay, now, actually, okay, now we're going to do the double derivative. So we're going to differentiate. So differentiate that again. So let's do that. So we just using the one before. So now we will be 2 over 3 times by negative half times by x to the power of negative half minus 1. So 2 cancel. So finally will be O over 3 times by x to the power of negative 3 over 2. So now we can return into 1 over 3. So that's x to the power of 3 squared. Now, if we want to find out what is, so if I give you another question, say if I want a double derivative of 9, so what's the answer? So let's say, okay, so therefore double derivative of 9, substitute. So we'll put a 9 into the equation. So the answer will be negative 1, 3 divided by 27. So the answer will be 1 divided by 81. So that's the value. So you can substitute into the second derivative function. All right, so this is another example. Now we're going to continue to do example 3. Example 3, I'm going to give you a little bit of more complicated example. So example 3. So let's say we have a fx equal to x squared multiplied by log x, log is e based, 3x plus 5. So what is double derivative? So let's do the derivative, first derivative. So obviously this is a product rule, so we're going to use product. So it'll be 2x times by log 3x plus 5 plus x squared, so 1 divided by 3 x plus 5, then use chain rule, times by 3, so 3 on the top. Okay, now we simplify to 2x log x log 3x plus 5. Then you have plus 3x squared divided by 3x plus 5. All right, now we do a double differentiation. So we're going to do, this time we're going to do two sections at differently. So we do the first section first. So do this product rule. So there will be 2x here. So we're going to do 2 times by log 3x plus 5, then plus 2x 1 divided by 3x plus 5, and times by 3. So that's the first one, product rule. Then we do the second one is a quotient rule. So we're going to use quotient square. So do the 6x times by 3x plus 5 minus then the 3x squared times by 3. So finally, simplify again. So this will be, sorry, this will be here times. So it'll be 2 log 3x plus 5 plus 6x divided by 3x plus 5 and plus, so expanding brackets, 18x squared plus 30x minus 9x squared divided by that. All right, so this is a pretty long one. So let's do this simplification. So we're going to continue to next page, probably x. All right, let's do simplification. So 2 log 3x plus 5 plus 6x 3x plus 5 3x plus 5 squared. So the answer on top will be 9x squared plus 30x. So in this case, I'm going to simplify it again. So if I were going to continue simplification, so we're going to make common denominator. So it'll be 3x plus 5 square. So we're going to do, okay, so that means here 2 log 3x plus 5 times by bracket 3x times by 5 square plus 6x times by 3x plus 5 plus 9x plus 3x. All right, so that's the couple of more steps to go. So we have a 3x plus 5 on the bottom. So 2, I might put this in the front. Expanding brackets, be 18x squared plus 30 x plus 9 x squared plus 3x. Sorry, my apology here. We maybe missed a 0 here. So it should be 30 here. My apology there. All right, so now we can see our terms a lot shorter now. Two, 3x plus 5. Collect lot terms will be 27x squared plus 60x. All right, so that's the final expression. So pretty long, but at least we simplified using um, algebra. So double derivative is not hard as long as you do step by step. So do first derivative first, then you differentiate the first derivative to get the second derivative. Okay, that's it. Today we talked about this formula. So if you can write down the formula into your book. So this is important notation to understand. Then practice some of the questions in your textbook. Thank you for watching. See you next lesson. Bye.